Hello, my viewers. My name is Terry Menekwenyong with Sunday, and I welcome you all to my PAU Forum channel. Now, in my presentation today, I will be treating this or what is in the board now, because this was a question someone sent to me. What the person experienced in his former factory. I don't know whether it's own a factory or it's a process engineer or a chemist, but that does not mean what concerns us is how to treat this question of top edge and shoulder split in its own or forming block. That falls under troubleshooting. I did say that troubleshooting means correction from unsound block for you to have sound block. That is a problems that you need to solve that may arise as a result of imbalanced chemical reaction or from the forming plant. But this case is from the raw materials. I was impressed. The reason in that the person was able to cap this out to me. These are technical terms. Shoulder splits and sorry, they should be easier. Shoulder splits and top edges. That is a kind of defect in the foam block. But before I proceed, I believe the person that asked that question experienced this kind of sign. If I may, be in the same track with the person, this is a foam block. Now, this is coming from 4 plates to the cutoff. Now, this is the shoulder. I believe this is the sign the person is trying to talk about, ask me about, okay? So, this is the shoulder. This is shoulder of the foam, shoulder. Okay? This is now split on its own. This is what we call splits. Okay, at the shoulder. Now, looking at this, it still center us, taking us back to polymerization reaction. By looking at this while you are foaming, as a process chemist, a foaming engineer, you know that your polymerization occur late. This is late polymerization or occurrence. Okay, this is a late polymerization or occurrence. Late polymerization occurrence, there are several factors that could lead to the temperature and the use of your thin catalyst in that reaction. Because the thin catalyst here is not sufficient. It could be sufficient, but because of the temperature is a bit cooler. So it will make the stenol, it will counteract the stenol of that particular formulation that you were using, making it seem like it is insufficient as a result of temperature. So it will make this polymerization occur late. Now, you see, foam is made up of windows and struts. It's like this. This is a foam. Okay, let me use this one. This is a foam. Inside this foam, you will see something like this. But you cannot see it with the help of your naked eyes except the use of electron microscope. Now, inside this is a strut. It's a kind of a bridge. Okay? So this is a window. So these cells develops too early. So at that point, the cell wall easily release the CO2 under gas pressure. As it releases it, it affects part A. So this part A now share it to all of them, okay, causing these problems. That is the thing. So the problem will continue until it is corrected. Now, how can you correct it? Thin catalyst, temperature. I understand some location. There are some countries that naturally their, how do I call it, their atmospheric temperature is always very cold. So people that are operating PU foam production in that environment can preheat some of their raw material like water, okay, to enable the polymerization reaction to well activated. You understand? But in Nigeria, our atmosphere is well at times it's cold, at times it's hot. So here one should be able to regulate the temperature, okay? Because when you have this idea that let me cool my raw material temperature, you end up making your production not economical because you are going to require much additive, much raw material to get it right. I don't say don't chill, but not too much. And at least there is a global standard you can maintain it. For box former, I know the challenges you are facing. Most of you do not cool your chemical, but if you can find provision to control the temperature of your raw material, you also have a perfect blood in this regard. So this polymerization reaction occur too late, okay? That is why you have shoulder split. But when it is soon, what will happen? It will restrict the CO2 release. So the cell wall will under suffer. It will try to release the CO2 under gas pressure if it could not. So making the internal gas pressure of the system fall below the atmospheric pressure. So in that case, the foam will shrink. So the two major effects also have negative impact on the block split and shrinkage. So in this case, you have to balance them in proportion through the temperature and regulation of your catalyst. I hope this is very, very interesting. Continue to like my page, share on your notification button so that whenever I upload a new video, you'll be notified. Thank you, my viewers. Bye bye. I love you all.